Our next unit is gas laws part 1. We are going to have 2 separate units on gas laws. In our first unit, we are going to focus on volume, pressure, and temperature and how that impacts the behavior of gases. All right, so in today's notes, we are going to really be going over 4 major gas laws. All right, again, we're going to be looking at volume, pressure, and temperature with these. Okay, this is supposed to scroll through. There we go. Our first gas law is Boyle's law. Boyle's law shows a relationship between volume and pressure. With all of these laws, we leave certain variables constant, and then in order for us to look at the relationship between others. All right. So in this case, the temperature is going to stay constant, and this entire unit, as we said, the number of particles is going to stay constant. So as volume decreases, so you can imagine as a container gets smaller, all right, you have less space for the particles, okay? And if there's less space, then there's going to be more collisions with the sides of the container. And we know collisions with the sides of the container is what causes pressure, all right? So more collisions means more pressure. So as volume decreases, because we made that container smaller, the pressure is going to increase. When you have a relationship where one thing goes down, therefore something else goes up, we call this an inverse relationship. I'm going to show you first this equation, and this equation here, the VP is equal to K. That K just means that things are staying constant, and in order for this number to stay the same, as volume, V, goes up, P, pressure, has to go down. That's just kind of a generic equation that we use to represent an inverse relationship. The useful equation, and that's why this is boxed in, this is the one you want to put a star by, all right, is the equation that you're going to use to solve problems. So we have V1, P1 equals V2, P2. The ones stand for initial. So your initial volume times your initial pressure, okay, those will be given to you, are going to equal to your final volume times your final pressure. All right, and you're just going to plug your numbers in, determining what your initial pressure, volume, etc. are. Plug those in and then algebraically solve for them. Okay. In your notes, you have 2 practice problems right ahead. And so if you want to pause this video and go on ahead and do those practice problems, that would be great. All right, so let's take a look at these 2 practice problems. In number 1, 250 mils of a gas at 150 kPa is moved to a volume of 150 mils. What is the final pressure? All right, so my initial volume, my V1 is 250. My initial pressure, my P1 is 150. It's moved to the new volume, so 150 is my final pressure. And I want to know, my final volume, milliliters is volume, and I want to know what the final pressure is going to be. So this is my equation, this is my Boyle's law equation, V1, P1 is equal to V2, P2. I'm just going to algebraically, I like to do my algebra first before I put my numbers in. That's really up to you. All right, but P2 is then going to be equal to V1, P1 over V2. And when you do this, the answer, and I made the math easy on this one, the answer ends up being 250 kilopascals. Couple things when it comes to these problems. Make sure that your units match up, all right? Milliliters and milliliters, great. Kilopascals is the pressure we put in, so kilopascals is the unit of the answer. Always remember you must have units. All right, number 2, correct 333 mils of gas. All correct means is just, let's see what the change is going to be. All right, so correct 333 mils of gas at 199 kilopascals to the volume it would occupy at standard pressure. So in this case, we're looking for the final volume. Remember, standard pressure is 101.3 kilopascals. We learned that last unit. That's not going to go away. All right, so my initial volume was 333. My initial pressure is 199. My final pressure is standard pressure, which I remember from last unit is 101.3 kilopascals, which gives us about 654 milliliters. Again, please don't focus so much on your significant figures. Just make sure you have a reasonable answer and that it is pretty close to mine. All right, so let's move on to our next gas law. And our next gas law is Charles's law. All right, Charles's law shows the relationship between volume and temperature. In this case, the pressure and the number of particles are going to remain constant. So as temperature increases, the particles move faster, and in order for that pressure to stay the same, because we want that to stay constant, you have to make that container bigger. All right, so this is assuming we have a container that will allow it to get larger, and we're making that assumption. All right, so as temperature increases, volume increases. All right, as one goes up, the other goes up. That's a direct relationship. All right, for our little equation here to show as one goes up, the other must go up to keep K constant. Again, this is not the one you're going to use. Here's the one you're going to use, this useful equation here. V1 T2 is equal to V2 T1. That's the way I like to memorize it. I have it written over here. Some people like to keep their volumes on one side and their temperatures on the other side. Totally up to you how you want to memorize this, but either one represents Charles's law. Now, when we are dealing with temperature and gas laws, you absolutely must do these calculations in Kelvin. I'm going to give you the temperatures in Celsius, and remember to convert from Celsius to Kelvin, we're going to add 273 to that Celsius temperature. So if I tell you to do something at standard temperature is 0 degrees Celsius. Please remember that and put a star by it. 0 plus 273 is going to be 273 Kelvin. This is super important. Gets the star. Make sure that we're good with this. All right. Ahead in your notes, you have 2 practice problems with Charles's law. If you would like to pause the video and give those a try, that would be a great idea. Okay, so let's go over these answers to the Charles's law problems. All right, number 1, what will be the volume of 100 mils of gas if the temperature changes from 125 degrees to 10 degrees? So we can already make a prediction, okay, because we do know it's a direct relationship. We are lowering the temperature, therefore the volume should lower as well. So let's see if that happens. Again, here's my Charles's law equation. V1 T2 is equal to V2 T1. I like to do my algebra first. All right, I then plug my numbers in, remembering that I must change my Celsius temperatures to Kelvin. You have to do that for gas law problems. When you plug all of that in, you should get about 71 milliliters. We started at 100. We predicted it would go down, so that makes sense. All right, so let's look at number 2. You have 500 milliliters of a gas at standard temperature is compressed to 75 mils. What is the new temperature going to be? All right, so we are lowering the volume. We expect the temperature to lower. So let's see what's going to happen. I'm now solving for T2. All right, here's my equation. Plugging my numbers in. What is the new plugging my numbers in, again, remembering that my temperature has to be in Kelvin. I told you that it is at standard temperature, which is 0 degrees Celsius, so it's 273 Kelvin. When I solve for this, I'm going to get the answer in Kelvin, but I asked for the answer in degrees Celsius. So all I'm going to do is I'm going to take that 41 Kelvin, subtract 273 from it, and I get negative 232, and I should have degrees Celsius written on there. I just don't. For number 3, I apologize, I don't have the work written out on here. What will be the volume of a balloon if at 25 degrees Celsius, the volume is 500 mils and the temperature is changed to 35 degrees? You can certainly do that one on your own, and you should get about 517 mils. Okay, great. All right, let's go to our next slide. Okay. All right, so our final 2 gas laws. Let's first look at Gay-Lussac's law. This shows the relationship between pressure and temperature when the volume and, of course, number of particles are constant. All right. If the volume is constant, so you can think kind of like a steel cylinder, okay? As you increase the temperature, you're going to get more and more collisions with that container because the container is not changing to accommodate you. All right, more collisions means greater pressure. What eventually will happen is if you continue to increase that temperature, you will get to a point where that container can't take it anymore and you will end up getting an explosion. All right. Okay. what's great about these gas laws is that they can all be combined into what we call the combined gas law. All right. So it allows you to change both temperature and pressure. It's going to combine Boyle's law, Charles' law, and Gay-Lussac's law. Here is the equation for your combined gas law. P1V1 T2 is equal to P2 V2 T1. Okay. Again, some people like to keep all their ones on one side and all their twos on the other. This is another way to write it. All I did was algebraically switch it around. Please use the one you're more comfortable with. Remember, anytime that you are dealing with temperature and gas laws, you must change that to Kelvin. What's really nice is with the combined gas law, this is really the only one you need to memorize, because let's say on here, all right, that we decide to keep pressure constant. Well, you would just take it out. And as soon as we did that, look, we have Charles's law. All right. You can do the same with the other two. All right, so you have a couple final problems in your notes. Go on ahead and pause the video now, and you can do those. All right, I'm going to continue on. Okay, so here we go. Number one, a gas at 155 kilopascals and 25 degrees Celsius has an initial volume of 1 liter. The pressure of the gas increases to 605 as the temperature is raised to 125. What is the new volume? Well, I can see all my variables are changing. I want to use that combined gas law. I'm solving for V2. Again, I like to do my algebra first. Okay, I'm then going to plug those numbers in, remembering to change my Celsius to Kelvin, and you should get about 0.34 liters. Okay. Number two, a 5-liter sample has a pressure of 107 kilopascals at a temperature of -50. If the temp is raised to 102 and the volume expands to 7, what will be the new pressure? Same situation using combined gas law and going ahead and solving to get about 129 kPa. All right, great. Okay, this is the end of your notes. If you look in my notes, you can see that in previous years, we've gone over a couple more gas laws. We're not going to make you responsible for those. So at this point, what you should do is the practice sheet that I have up for you, and I'm going to find that. It looks like this. Okay, and this is under our new gas laws module and where you can find this. I just want to note, as you go through, you're going to have some Boyle's law problems. Scrolling. Some Charles' law problems, great. Ooh, God, went too fast, must have done you. Some Gay-Lussac's problems. Now here, Avogadro law and molar volume. We're going to actually wait and cover this in the next unit. So please don't worry about those three. They're on this worksheet and I don't have the ability to edit it out. So just ignore those three, but please continue on to these combined gas law problems. All right, fantastic. Okay, so for this week, guys, what you should be doing is watching this video. Completing this practice sheet, you will find the answers to this on the modules. All right. And on Friday, I will have a check for understanding for you. Please always check all of the announcements. I will put additional resources on there for you, and I hope you have a great day.